All right, so what makes this problem particularly difficult is that there's two rules that aren't used all the time or too frequently, but at least once a test. So I'm excited that they're combined in this question here. And what they're asking us to do is figure out what a minus b is if we know all this other stuff. And that is that, well, let's just let that speak for itself for a second. And then we know x is greater than 1. The only reason they're saying x is greater than 1 is because they don't want you to say this is 0 and then the whole thing is undefined. Other than that, this is not useful information. And then a plus b equals 2. And when I see that, I'm like, well, a plus b equals 2. Is there a way to turn this? Like, was it negative a? Like, if I multiply this by -1, the problem is that then that becomes negative b, and that's different from a minus b, and, you know, equaling -2. So that doesn't work. And I see that they're kind of giving me a hint where I see a and b being listed here, but it's being written as exponents. And they're telling us that those exponents are equal to this variable with this exponent. So I know that that's a hint to rearrange this as let's write it as a division problem. Squared xb squared equals x to the 16th. Because all these bases are the same, what that means is we can look at these exponents, including the letters here that I have now in red, and we can just write that as its own equation here, where it's a squared, and because we're dividing here, minus b squared is equal to 16. Now, I see all these squares, and it's so tempting to be like, oh, let me just square root both sides, and that means that a minus. That's not true. The square root of no, when you're dealing with adding or subtracting between two terms, you can't just square root both sides and easily just get a minus b. That's not how this works. When you see a binomial where you're seeing, or a trinomial where there's adding or subtracting between the values, you want to think factoring. And here, it may not be too obvious right off the bat, but we can actually see that this is a difference between two perfect squares. And what I mean by that is that this here, a squared, the square root of that is easy. It's just a. The square root of b squared is just b. And so what that means is we can factor this out into the equation of a minus b. I'm sorry. A minus b times a plus b. That is the equation for of a perfect square when you're factoring a perfect square. And then that's equal to 16. Another hint that we got to factor it this way is that they told us what a plus b is, so that does become useful here. Typically when they're giving us formulas, those tend to be useful. I think what tends to be useless is when they're giving us a story, and it's like Johnny was wearing red socks and blah, blah. Sometimes that stuff is useless, but here it's helpful. And we see that a minus b times 2 equals 16, which means that a minus b equals 8, which must mean that the answer is A.